In November 2021, the world was shaken by perhaps the most critical cybersecurity crisis of all time. Log4Shell, a vulnerability in the Apache Log4j open source project. What made this vulnerability so lethal was that it allowed attackers to import and execute malicious code into any app using Log4j dependencies. This resulted in some attackers achieving full remote code execution in some environments. While quick action by the tech vendors and open source heroes helped minimize the severity of the crisis, the risk is far from over. So, how can companies prepare for similar and potentially even bigger security threats in the future? There are 3 DevSecOps practices that can help. 1. Segment your network. Identify and document all of the authorized data flows your app is allowed to make. This helps you establish a data flow diagram approach to threat modeling, creating barriers to prevent risky communication flows. 2. Test for known vulnerabilities. There are multiple approaches to identifying vulnerabilities for applications. For commercial off-the-shelf software, implement a traditional vulnerability management program. Here's how to do it. Develop a plan in coordination with system owners. Implement a vulnerability scanning solution against known applications and networks. Assess, triage, and assign remediation activity to the appropriate system or data owner. Track progress and provide metrics to leadership. Such metrics should include the current risk posture and the time interval between vulnerability identification and remediation. Configure controls such as linting tools, SAST tools, or DAST tools to identify and correct code with obvious vulnerabilities or dependency calls as part of your build pipeline, preventing them from being deployed into production. For newly discovered vulnerabilities, you can use tools such as Anchor's SIFT to establish a software bill of materials, SBOM. Then cross-compare that output using a vulnerability scanner such as Gripe. This entire process can be fully automated, giving you visibility to remediate the issue as soon as it's identified. 3. Sign artifacts and code. Finally, it's important to establish artifact flow integrity to defend against software supply chain attacks. Leverage the in toto framework using cryptographic signing, where building steps are defined in a layout and then signed by a project owner using public key cryptography. The future will have more open source software, not less. Fortunately, DevSecOps can help you create a strong foundation to prevent devastating cyber attacks. Want to explore a DevOps strategy for your business? Talk to our experts. The link is in the description.